So today's video is called GCF and LCM. So what does GCF stand for? It stands for the greatest common factor. And what is the greatest common factor? It's the biggest factor that two or more numbers have in common. So basically it's the biggest number that two numbers can both be divided by. And then what does LCM stand for? It stands for the least common multiple. And what is the least common multiple? It's the smallest multiple that two or more numbers have in common. So how do you find the GCF for a set of numbers? You basically have two options. The first option is by using a Venn diagram. The second option is that you're going to list all the factors for each number and find the biggest one they all have in common. And sometimes the problem with option 2 is if you don't list all the factors, you might actually miss the greatest common factor. And how do you find the LCM, or the least common multiple, for a set of numbers? Well, basically there's pretty much just the one option, and you're going to list the first 5 multiples for each number and then try to find the one that they share. And if you can't find one, you're going to list 5 more multiples and then see if you can find one then. And you just basically keep listing multiples until you find one that they have in common. So let's look at this example. So this example asks us to find the GCF for 8 and 12. So we're going to start with our first option, which is a Venn diagram. So we're going to have to start by creating a factor tree for both numbers. So I want to create a factor tree for 8 and 12. So the first thing I have to ask myself with the number 8 is, well, what multiplies to give me 8? Well, I know 2 multiplies to give me 8, and I know 4 multiplies to give me 8. And then I have to ask, is 2 a prime number? And the answer is yes, 2 is a prime number, so we're just going to go ahead and circle that. And then we have to ask, is 4 a prime number? And no, it's not, so we're going to actually keep going. So we're going to draw 2 more branches from the 4, and then we ask again, well, what multiplies to give me 4? Well, we know 2 times 2 multiplies to give us 4. Again, we want to ask, is 2 a prime number? And we saw from the last branch that 2 is a prime number. So we're going to go ahead and circle both of these 2's and then stop. And then since we have no more branches to fill in, we know that we have found the prime factorization for 8. So now we're going to move over here to 12 and do the same thing. Find the prime factorization for 12. This time I'm going to use 4 times 3. And then again I ask, is 4 a prime number? And we know, nope, 4 is not a prime number. So we will draw 2 more branches and keep going. And then we ask, is 3 a prime number? And the answer would be yes, 3 is a prime number. So we're actually going to circle the 3 and stop. So now we have to ask, well, what multiplies to give me 4? Well, again, we know that 2 times 2 multiplies to give us 4. So once again, we're going to circle both of those 2's because they're both prime numbers and stop. So then the second step is to actually use what you did in the factor tree to create a Venn diagram. So then the numbers that I circled here, I'm actually going to put down here at the bottom of my Venn diagram. So I know that the prime factorization of 8 is 2 times 2 times 2, and then the prime factorization of 12 is 2 times 2 times 3. And when you create the Venn diagram, every number that they have in common, you're going to place in the middle where the 2 circles overlap, and all the numbers that are different go on the outside. And this is just like what you guys do in language arts or social studies. When you have a Venn diagram, whatever's in common goes in the middle, and then whatever they have that's different goes on the outside. So when I look at these numbers, I'm looking for pairs that they have in common. So I look here and I see, well, I see a 2 here and I see a 2 here. So that means they have one pair of 2's in common. So then I'm going to put the 2 in the middle. Then I look here and I look here and I see another pair of 2's that they have in common. So I'm going to put that also in the middle. So what we see is that the 8 and the 12 both had 2 2's. Then I see, well, what do they have that's not in common? Well, I see that the 8 has an extra 2 that I'm going to put over here. And then the 12 had an extra 3, and I'm going to put that over here. And then I see in the middle what's overlapping are basically the 2 2's that they had in common. So after you create the Venn diagram and you fill it in, you're on to step 3. And step 3 is that you're going to multiply the numbers they have in common together. So I know that the numbers they had in common was 2 and 2. So I know 2 times 2 gives me 4. And that actually means that the greatest common factor for 8 and 12 is the number 4. The second option is that you're basically going to list the factors for both numbers and find the biggest one that they have in common. So as I look up here, I'm going to list the factors of 8. And we're going to use a T-chart since you guys like that the best. And I see one factor pair for 8 would be 1 times 8. And then I know 2 is another factor, and it would be 2 times 4. I know 3 is not a factor, and then 4, we already have it up there, so we know that we're done. Then I come over here and I'm doing the factor tree for 12. And I know, well, 1 times 12 gives me 12. Then I try 2 and I know, well, 2 times 6 gives me 12. Then I can try 3 and I know 3 times 4 gives me 12. And then I can try 4 and then I see I already have 4 on here, which again lets me know that I'm done. And again, I'm looking for what do they have in common, and I see again they have the 2 4s, and that's the biggest number they have in common, because they also have the 2 in common, but remember we're looking for the greatest common factor. So they have the 4 in common, so that again means that the greatest common factor for 8 and 12 is 4. You can also find the greatest common factor for 3 numbers. So right now we have these 3 numbers that we want to find the greatest common factor for, which would be 9, 12, and 15. So again, what we want to do is we want to use the Venn diagram option to find the greatest common factor. So I'm going to do a factor tree for 12, 15, and for 9. So I have to think, well, what multiplies to give me 9? Well, I know 3 times 3 multiplies to give me 9. And again, I ask, is 3 a prime number? And we know that yes, 3 is a prime number. And since we circled both of the 3's and there's no other branches, then that's the prime factorization. Then again, I come back to the prime factorization for 12. I know what multiplies to give me 12 would be 3 times 4. Again, we know that 3 is prime, so we can circle that. And 4 is not prime, so we're going to draw 2 more branches. Then again, we're asking what multiplies to give me 4, and it would be 2 times 2. So then again, I'm looking, is 2 a prime number? The answer would be yes. So then I circle both of the 2's. Then I come over here to 15. What multiplies to give me 15? And I know 3 times 5 multiplies to give me 15. I ask, is 3 a prime number? And the answer is yes. And then I ask, is 5 a prime number? And again, the answer is yes. So now I want to come down here to my Venn diagram. Now I have 3 numbers. So I have 3 circles representing my Venn diagram, and then where the 3 circles overlap is where I'm going to put the numbers that they have in common. So I'm going to write that prime factorization for 12, 15, and for 9. And then as I look, I see that the 12 has a 3, the 9 has a 3, and the 5 has a 3, so they all have a 3 in common. So I'm going to put the 3 in this area where they overlap. And then I'm going to look again to see if they have anything else in common. And there are no other numbers that all 3 have in common. So the only number that they all 3 have in common would be the number 3. And I'm going to put that here where they overlap. And what that actually means is that the greatest common factor of 9, 12, and 15 is 3. Now another way for me to find the greatest common factor is by listing the factors. And this time we're going to use the rainbow method. So I'm looking again at the number 9, the number 12, and the number 15. So when I do my rainbow, I know my first hump is going to be 1 times 9. Then I have to think what else gives me 9, and that's going to be 3 times 3. Then I'm going to come over here. I'm going to do my next one. What multiplies to give me 12? I know 1 times 12 can multiply to give me 12. I know 2 times 6 can multiply to give me 12. And then I also know that 3 times 4 multiplies to give me 12. Then I'll come over here and I'm going to do 15. I know 1 times 15 gives me 15. And I also know that 3 times 5 also gives me 15. Again, I'm looking to see what's the biggest number that they all have in common. And the biggest number is 3. So again, we know that the greatest common factor of 9, 12, and 15 is 3. So our last example is finding the least common multiple for 4 and 9. So our first option is we want to list the first 5 multiples for each number and then try and find the one that they all share. If you cannot find one, then you're going to list 5 more multiples and try again and find one that they all share. And you're going to keep adding on multiples until you find one that all the numbers have in common. So I want to find the least common multiple of 4 and 9. So the first step is to list the first 5 multiples for each number and look for a common multiple. So remember, the multiples are actually what you see in the timetables or the multiplication chart. So if I'm thinking about the multiples of 4, I would first start with What's 4 times 1? Well, I know 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and 4 times 5 is 20. Then I'm going to do the same thing with 9. 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, and then 9 times 5 is 45. So I'm going to be looking to see, is there a number that they both have in common? And when I look, I don't see any numbers that they both share. So that means I actually need to add 5 more multiples for each number. So I'm going to go back. So these are the original numbers that I have. So now I'm going to actually add 5 more multiples. So then I know 4 times 6 is 24, 4 times 7 is 28, 4 times 8 is 32, 4 times 9 is 36, and 4 times 10 is 40. Then I'll add 5 more multiples here. 9 times 6 is 54, 9 times 7 is 63, 9 times 8 is 72, 9 times 9 is 81, and then 9 times 10 is 90. And again, I'm going to look at my list and still look for the smallest number they have in common. And I actually see that they actually have the number 36 in common with each other, which tells me that the least common multiple for 4 and 9 is 36. One of the main things that you want to be careful with is mixing up multiples and factors, which, like I said, is a big common mistake that students make. So you want to make sure if you're asked for factors that you're looking for factor pairs, 2 numbers that multiply to give you that number. And then if you're asked for multiples, you got to be thinking about the timetables, the multiplication chart. Okay? All right, so don't forget to teach the tiger something you learned in today's video.